Okay, it looks like we are live. So welcome back. Today I'm going to be continuing to work on my virtual machine. So I did get a little bit of work done since the last stream. So the first thing, I added a new flag to the build.sh. So it's -w, and then it basically builds a Windows build, so a .exe. Now I haven't tested it on an actual Windows computer, but I tested it through Wine, and it is mostly working. So I will sort of get into what's not working. Bitrate is unstable. Alright, but, so yeah, that works. So I can build for Windows, and that, it also builds the Linux one, but yeah. So now we have the .exe files, these two, so TASM and tired. So then I can go in here and we can run TASM, Fibonacci, and then the .tim as well, and it prints out just like how you would expect. And that is running through Wine, so I can do Wine, and that's what it's running through. It's just as an executable. And then we also, yeah, it also works with the Hello World. Actually, I am using the wrong one. Not.exe, that's what I meant to be using. It does work though, so tired.exe, hello world.tin, and there we go. You can see that works, so the write works. The problem is that the open syscall does not work. So if I run that on open.tin, yeah, so we can get that, and then unexpected native call. So it doesn't work. I'm not sure that that's actually, because it was doing something a little different earlier, but I think I might have messed something else up. Yeah, okay, so I think I did break it. But that's okay, because it wasn't working on Windows. You're gonna have to trust me on that. It did actually do that though. Yeah, but basically the thing is it's not working. So we'll need to fix that. And I think that the best way to go about using that is using the C standard library rather than the syscalls. So not that. So in essentially tim.c. Whoops. All right, yeah. In here we have native open, and it's using open. Instead, should probably be using fopen. That does change some stuff. So let's look at open. So you need to provide path name. All right. So I think it might be the same thing. I don't think we need that though. So something like that should still work. So let me file that. And we have problems from file. Oh, okay, so it doesn't return a file descriptor like that. It returns the actual file. So yeah. So we can't use it exactly like that, like how we could the other way. So I will have to adjust for that. But I think it should work now. So let me run it. I'll use the Windows one. Open.tim and then test. Segmentation fault. Yeah, so that's actually probably because I should change that. So yeah, I'm not sure what that's about. Alright, yeah, so in here, let me change this. Alright, so this, let's just, we can just do it as a pointer, so, like that, and that will still be valid. So, if we build that, I went to, alright, so it doesn't like that. What is that supposed to be? Yeah, okay, so it's actually, it's a string that you pass there. So I forget. Oh yeah. All right, I'm not sure what this. I need to delete the swap file. But yeah, for this we don't actually want to pass these. We want to pass like read or write. So we'll default to write, but we can still basically we can have it correspond with certain things based on what it is. But yeah, so we'll just default to write. Let's build now. Unused variable. That's okay. So let's run parsing open.tim. Okay. Back underflow. Alright, yeah, so I think that is in the open.tasm. Let's see. Oh, so yeah, I actually was messing around with I forgot to actually I haven't shown that yet. I was messing around with the strings. Let me just delete that swap file really quick. Give me a moment. Alright, so that should be better now. So let me, whoops. Quit, and then open it, and there we go. So, yeah, so I was messing around with strings, and now they are null terminated, rather than providing the length. So you can see here, we interpret it as a character, and use the pointer, and then here, we can actually subtract, the size of word, which is the, well, it's the size, between each different pointer. So then this will be equal to the next character on it, and then you just set the last one to be this. So the way that works in the parsing.c, right here, we set the first we push the null termination, and then we push the actual text. And the thing is that let's see, it is backwards, so we do have to reverse it once we retrieve it. Yeah, but that's all right. All right, go back. So I didn't actually change that. So unused variable. Yeah, let me just comment those out if you're not using that. Oh yeah. So I didn't actually account for that. Well, I don't. So let's go into text and then vim in here, and let's not push these anymore. So push one. So that's the that is just pushing whatever. And then here, so we're trying to write to the file. So, oh yeah, because it doesn't return the file descriptor anymore. So this writing won't work, because we need to use the pointer rather. So we will need to update fwrite for that to work. But I think we can comment it out. So we can leave it closed. We can remove that and the dupe. And now, I open .tin. Yes, and it should have created an empty file. Yeah, alright, so then to write to it, we need to update write to be using fwrite. Yeah, so rather than write, we are going to do fwrite. So the file descriptor, we need a pointer instead, right? So let's see. Yeah, so right here, fwrite, yeah, so the pointer, and then this is the stream. So the last one is what we are writing to. So that's sort of what the, so we're just gonna read one byte at a time, and then the length. Yeah, so I think we want to do like stir one length, and then this can be well, so the file descriptor that we pop off will be the stream, right? So stream, and then we'll pop it as pointer. Yeah, and so let's see. So that's gonna break a lot of stuff because it is different now. Argument 4. So, oh yeah, because I forgot to change that, so it's not an int, but rather a, used to be a void format thing. Yeah, so now in test, actually vim open.parsing, and we want to get all this stuff. So open.tin test. All right, and then if we get test, so it didn't work, but it did not throw any errors, because I guess we don't really handle any error. Not testing. So let's see what. So it should be a pointer on the top, but it's kind of hard to tell. So let's actually print what all of the values are when we actually get them. So down here, yeah, we'll just print the stream, stir, and the length. So, well, actually the length doesn't matter. So yeah, the stream, and then it's a pointer, and then the stir we can print as a string. So stream and stir. And let's build that now. And open.tin. Yes. Nil. Alright, so it didn't work. So we didn't pop it off properly. So it's in the wrong order, I presume. Open. My Wi-Fi might be dead. Okay, I think we're still alive. Not very good though. The stream may be dead. It's just loading. I'm gonna continue. Hopefully it starts working. Because my Wi-Fi is still up. Yeah. Okay, hopefully it's working. So let's go in here. So we push 1, so we don't actually need to do that. Do we? Well, so we push this, and then the file descriptor is not that. So const void pointer. Uh-huh. So let's see. So, we don't. This might be breaking actually because we don't want. Alright, yeah. So that's more correct. It's still stack underflow. Probably because we popped something out that we didn't want to pop. But yeah, so that did work now. So we don't need these at all. So what did we, is it here? Duplicate that, we swap it there, pop it, write it, close it. So are we, so what's the issue with this? So I think the stream is gone. Maybe it is not. Is the stream dead? It looks like it's just buffering, but I can't tell. Okay, I think we're good. Okay, yeah, so back to it. So that's working now. Just this one overflows, so, or, underflows. So we push that, and then push the size to malloc, and then we push the length of that, send it in, read, open, so we duplicate it. So why is it, so if we get rid of this, then it doesn't. Yeah, so then there's no underflow. So it's the close that is doing it. So let's remove test. So we need to, I guess, just duplicate it again. Alright, well, let's try doing that. It's still underflow, so that's kind of strange. Alright, well, let's just not worry about closing it right now. It might be, you know what? It's because we're not using F close. Yeah, so let's do that next. Vim C. So in native close, we want to use F close. And let's make this a pointer. Stream, and then interpret it as pointer. And let's try that. So let's build it now. And that doesn't work. What actually does F close take? F close. Yeah, so it just takes that. Did I not change it to not be an int? Oh, we need to do that. There we go. Alright, so now let's not duplicate it twice. Fire, open up Tim. So it still underflows. And let's see. Fire, open dot Tim. Yeah, I'm not sure why it's underflowing. So let's print Depth here, and let's see. So this, I'm assuming, is where it's under. Test and no, so it's before that, so it's in the right. But the right successfully completes. Yeah, so the right, we're putting out that. Perhaps close is not down to the right thing. So close is 3. I'm pretty sure that's right. Native 60. So yeah, I'm gonna implement that. But yes, that should be working. So I'm not sure what the issue is. We should also probably modify read to use fread. Let's look at fread. Fread. Yeah, so it works the same as the write, essentially. Yeah. But also I want to implement void native exit. So then we can actually exit with an exit code. Because that'd be pretty cool. Yeah, so you know what? It's because I put this in there. Yeah, it's supposed to be up here. I think that's what the issue was actually, why it wasn't printing. So exit will just pop off the stack. Code equals, make it an int 64. Code equals pop machine.add int, and then we'll literally just exit with the code. Yeah, so that will be good. But yeah, so let's test out that. I gotta rebuild it though. So now, got parsing, got 10 test, and yeah, so that is where it is underflowing. So the problem, actually, we want to, well, we're swapping it for that at 0, and that's where it should be. So we don't want to duplicate that. Maybe we don't want to duplicate it at all. Not 10, next. No, alright, so that breaks down. So we want to duplicate it and then swap it with 0. Get rid of the pop actually. Not 10, yes. Yeah, alright, so that doesn't work. So let's dupe pop, because we don't want 0 to be, we don't want 1 to be at the top. Then we write, so we should have it available there. Duplicates this one, puts it in 0 with, pop that off. That should be working. So I'm not sure why it doesn't. Yeah. Alright, yeah, we will figure that out. But first, I do want to test out the exit. So, yeah, I made it 60 because that aligns with, it's 60, with Linux syscalls. It's 60 is the exit syscall. I don't have to do that, but it makes it a bit easier to remember. I think, at least, for me. So if we build that, test. Let's then exit.parsing. And we'll just push exit, and then we'll write. We do have to push standard out, so let's import standard cache, and then we will just exit. Actually we have to push the exit code, so maybe we'll make the exit code, yeah, push 69. So then that's what we should exit with, assuming I did it right. Exit.pin. And I seem to have not done it right. So let's see, what did I forget? So we can push exit, and then that, and write. Alright, let me actually debug. What did I do wrong? So did we actually get to the exit? Or did I do something wrong with the write? Exit. That's not right. Exit. There we go. And exit dot Tim. Alright, so we didn't get there, so it is with the right. So let's look at hello world. Did I mess that up? So we push that and then push standard out, right? Yeah, so I don't know what the issue is. Well, let's get rid of this then and just do that. And we don't need that. Chasm, exit that chasm. Oh yeah, we do need that because we have to include it. So, import standard defs dot dash. And then let's just echo the exit code. And that's for the wrong one now, so 69. Alright, there we go. So it did work. So that's good. My internet is dying. Yeah, but it did work. So yeah, so I don't know why the right doesn't work though. So it's because I modified it actually, right? So we can't just use standard out like that anymore. Because we're using F right. So alright, when we c.c and include H main F, or let's print F and standard out. So what is the value of that? Here we go. C dash O. Yeah, we're gonna do that, and then A dot out. So that is the value. Alright, yeah, so it is a pointer actually. So what is the pointer value of it? How do we like declare that then? So what is it? What is standard allocated? Because we need to be able to use that. Like how do you get this string? We could just add a switch statement to check what the value is and then set it based on that, but so it's the stream that is there. How do we get the stream? Alright, yeah, so I think that might be what we have to do is just let me remove a.out as well as c.c, and then let's go to here. So yeah, we need to get in native right. Basically we just have to check. Yeah, so the out will equal equal standard out by default, and then we'll just get stream basically, I think is what we can call it, and we'll just pass the we'll pass, well actually yeah, so the string so we can't really check that because we're calling it as a pointer. So we will have to do something different. So how do we get value of standard out? Let's see. How can we do that? Well, so let's do word, make stream a word, and then here we can do stream dot as pointer, and then so we can interpret that here. So get stream, we pass stream dot as int, and then basically up here we can make int. No, we'll do get stream, and it takes a word stream, and basically we'll do switch stream.as int, and in case of 0 return standard in, Case of 1, return standard out. Case of 2, return standard error. Default is return string. And I think that will work. Hopefully. So then we can get that. So yeah, we can do string equals that. And let's build that. And I seem to have made some mistakes. Yeah, actually, so we don't want to do this as int. We want to just like that. And now, all right, word to type void. Okay. Yeah, string dot as pointer can equal that. And let's see what else. So control, yeah, so we'll just return string there as well. And we don't break on it. Well, we return, so it should be fine. There we go. All right. So why is it still? Does it want me to break? Yeah, so we don't actually. Yeah, so that, we don't need that. Um, Stream.as pointer. As pointer. Okay, an invalid initializer. So, yeah, we don't want that. Oh yeah, so actually this isn't capital, so I can just like that, and there we go. And all right, so let's see. So if we go in here, and that's not the one that I wanted to use actually. Let me modify the exit. See, that still works. Yep. All right. And now, so we can exit from the code, or from the assembly rather, with an exit code. As in hello world, and okay, so that seems to work now. Based on whatever we input. So now, let's see if open.tin. Yes. All right, so it's still underflows, but it did write properly, so that's working. So it just underflows because of the way we are handling the write, I suppose. Probably in the get stir. Perhaps we don't want to do that actually. And cd test, and let's just run that. Actually, it's open. Okay, there we go. So that actually seems to have worked. Yeah. So, ooh, there is an extra bit there though. An extra byte. Yeah. So why is that? Whoops. There we go. So let me. All right. Length is that. So do we need to do? Nope, that's not it. So why does it do that? Why is there the extra little byte there? Yeah. So. But when we do that, it breaks it. So. Alright, let me fix that. And let's try it on the hello world then. What about 10? Yeah, so that one's fine. Yeah. So now it doesn't. Oh, but it does sometimes? And And all right, what? Oh yeah, because we provided too much, so or not enough. Hello, hello. Yeah, so there's the extra one. So that is an issue. All right, well let's print the stack here, and let's see what it looks like. Test player open dot tim test. So yeah, we have the pointer there at the end of the after we subtract everything. So what does fwrite return? We have it in here. Returns a size t. So would we use that? I don't think we have to use that for anything. That's just the error code, I presume. But yeah, so we have this. It doesn't print the rest of the. So why is that? That's point. Kind of strange. Why didn't it print the entire thing? Oh, but now it did. Alright. So remove text. Okay. Alright, yeah. So let's see. So let's so why is it cd text and that hasn't. Alright, actually let me do that again. Text, and let's cat text. Yeah, so there's the extra stuff there. Yeah, let's do, whoops. I want to plus one. And now, run open.chasm, open.tim. We'll type in the file name. And yeah, it underflows. So vim open dot, no, let's exit out of here. So we push one, then we push this, and that pushes all the things onto the stack. We push that, and malloc consumes it. Push 4 and standard in, and read consumes both of those, as well as what malloc pushes. So now we just have the hello world and the 1. And then we call open, which just uses, what is open? Open just has the one thing, right? And then yeah, it's just right by default. So that's what we've got. Okay, so open consumes the output of read, and then it should push. Does it push? Did we have it push the point? Yeah, it does. So it pushes that, and then we should duplicate that. So then the top 2 should be that. And then we swap with 0, so that should be 1. And 1 should be on the top. We pop off 1. So we sub the pointer on the top and the bottom, and in between we have the hello world. But that doesn't want to work. So I guess it removes the let's see. So let's print out the link. Okay. And link. And let's see what it is. Player open.tim. Okay. And so the length is 15. Alright, yeah, so that is fine. Why does it have the extra character? That's what. So that is an issue with the get string, I suppose. Let's see, I can get rid of this. Well, we're gonna need that because, yeah, we'll leave it for reference, so we remember. So the get stir from stack. So that must be going too far. Buffer index plus plus. Alright, let's see. If we don't read alley, Yeah, if we don't do that, right here, and we run it now, open dot tin test. Yeah, it still does. So, let's print the buffer. And I forgot a comma. And dot tin test. So hello world, and then it has that extra thing there. So that's not good. So why is that? So this shouldn't even work actually, I don't think. So it does. Current does not equal that. We go through this. Buffer equals current. Build, I wanna, there we go. Open dot tin. Yes. So for some reason, when we do that, it has the extra thing on there. So is that an issue in the hasm.c when we are pushing it? So we push that initially. Value, we push that. And then we push this. So can we print the value of, I guess we can't really do that because we don't have a one string value. But I suppose this we could just check the stir len instead of doing this. Well, so do we have to do, let's see, buffer, yeah, well, let's do that, and then rebuild this, and let's run this again. All right, and then we segfault. All right, so that didn't work, obviously. Yeah, so I think that this, let's do buffer index minus, and so we're gonna be overwriting stuff here, but I want to see what happens. So let's print the buffer, and then let's go here, and let's run that. Yeah, so hello world with double new line. Yeah, because it's because we have the new line. So why does it segfault now? That's at the complete end. Oh, because now we have the pointer at the top. Okay. Yeah. So that's what I was thinking. Yeah. So now we do have to actually do this here. So that's up. Up here we have to do length +1. And now if we do this, so that accounts for the character test, and it should have worked. There we go. All right, so that's what I wanted it to do. That's how I wanted it to work, and it works. So it's a little messy. I'm gonna have to go through and clean it up. I don't need that. So that was down here. We can get rid of this. Let's actually keep that, and then just do that. There we go. And we'll get rid of this, and let's rebuild it and make sure it works. Well, actually, let's make sure hello world dot casual. So that works. We are still printing the stack, so I do have to get rid of that. Open dot casual. Test, and that writes test. All right, perfect. So let's get rid of some of these print statements that we've got. So right here we have one. Don't need that. And then we have print stack, and we don't want that. So I think that is all of them. Tire open dot tin test. All right, and then let's cat test. There we go. All right. So yeah, we can modify that. So if I actually exit out of here, and if we look at open.tasm, we can make this say whatever we want, and it will automatically adjust the length of the string. So we can do like, this is a message. And then that should just work, assuming everything is working properly. And there we go. This is a message, so that's perfect. Yes. So we can write to files. And I don't know that we can read to files right now because we haven't updated the read yet. So I should probably do that. I should probably actually let me do this now. So let me push exit and then push standard in. No, standard out, I mean. Standard out. And then write. And let me make sure that works now. Because it's not working before, but it should have been working. And it actually prints out that. Why is that? Okay. Oh, you know what it is? Oh shoot. So that's a pretty big issue actually. The preprocessor sees this and then fills it in. So yeah, gonna have to do something about that. I can just do that to make it so I don't have to worry about it right this second. But so I will have to fix that because that is not good. Actually, if I just make it exit /n, no, I still don't think it'll work. I think I have to do something like that. Exit.tin, and there we go. Yeah, so that is a bit of an issue. I think. Well, perhaps all the def keywords should use capital letters. So then, yeah, that might be a good idea. Yeah, I'll probably change that. But right now that is working, and actually the read I don't think will work. So once we update the read, it should work properly on Windows as well. So let me do that. So I think we still have read in here, fread. So we need to get, well, let's look at read, how it's working right now. So this file descriptor, we want to instead get the string. So it's basically going to work the same way as the other ones, the write and such. So the buffer, yeah, that's the same, I think. Yeah, so that's what we're writing to actually. So this is actually we just call it pointer, and then the length, the size will always be 0. Oops. Yeah, we'll have that always be 0. And this actually returns a size t. So what can we do about that? Because we want to get the we want it to return the to write to it, we need the string. So how does that work? So let's look at return. On success, the number of items read or written. This number equals the number of bytes transferred. All right. All right. Let's see. So fread. So here we put the pointer. So that's the top thing. That is where we are writing to. So I think we need to do the same thing as in here where we get the string. Yeah. So pointer.asPointer equals getString. So that's what we'll call it. And then this is what we are reading from the stream. So I guess it should be called the stream. So that goes last actually. So we have 1, that's what we read by, and then that stream. So something like that. Yeah, let's get rid of this actually and make this a word like that. And we don't have to do this because yeah, so this is actually we want to, it is a buffer, so that's probably a more valid thing, because that's actually what we are using. So yeah, and then we write to the buffer. So that should all be fine actually. Yeah, so let me try that. We do have some issues. So expected file. Yeah, so it's actually supposed to be, we can just make it a void one. Void buffer, and then yeah, we'll just add that there, and that should work. Void. Oh yeah, so we need to interpret that as a pointer. As pointer, like that. And then that works, so let's see if it works. Kurt Rosenwinkel, if I pronounced that right, just followed. Thank you, I appreciate that. There we go. The notification went on. Alright, so let's see. So let me open that admin, not Tim, and alright, so it broke. That's okay. That's okay. So that is in here. The read did not work. Well, I think it's the read. Let me, is that where it starts to break? We don't need to recompile it actually. So where is it breaking it? Let me actually comment this out. And then build it, and alright, yeah, unused parameter, that's okay. Alright, so I think we have a different issue. Okay, so it was working a second ago. Let's see. So let me, yeah, what happened? What happened to make it not work? So what instruction is it breaking on? So the first one is open, but that was working. So let me try to print that. If I can type here, and let's see, build that. Open.tim. Alright, so we get there. Actually, yeah, so we're pushing this. So we do get all the way to open. But then it breaks. Okay then. So where is it? Is that right? No. Wait, hang on. Here, yeah. So let's do open. So make it there. So that means that the right worked. But we didn't. No, hang on. Yeah, we don't actually get there. Open right. Alright. So the read, oh yeah, it's trying to call read, but read doesn't do anything. Because that's what we're supposed to wait on. So, yeah, let me get rid of this. So how do you use fread? Let me look at an example. Am I doing something wrong here? So we get the pointer, that should be on the top, because that's what open should return. And then we interpret the pointer like that. Actually, we don't want to do that. Well, no, that should be fine, actually. Let's just not do that and see. Actually, let me then open that head. So we do push standard in. So we do want to do that. So that is, yeah, we can't get rid of that. So right here, we need to do that. Pointer, as int. Standard in. So it should be 0. Let's go to the defs. Yeah, standard in is 0. I'm not sure why I have it declared in this order. But yeah, so that should be fine. But it's seg faults. Okay. So read, All right, fread. Let's look at this. So fread, filling up C++. All right, so actually, do I want to swap these around? That could be the problem. That's supposed to go there. And then just get rid of that. There we go. All right, let's see. Is that what the issue was? 10.10. Or actually, that's not right. All right, so that didn't fix it. I think that's what we want to do, though, because looking at this, that's what it looks like. So do we want to switch these, though? Should this one be the buffer, and then this one's the pointer? That... All right, we need to do pointer dot as pointer. Yeah, that is here. As pointer. There we go. And now... Test. Okay. Make that test. Alright, there we go, it worked. Yeah, so it was just the order of things. Actually looking at this though, so yeah, so that's the order that we're supposed to do it. Size to be red. This is the number of elements. So yeah, the number of elements should be the length, right? So I think that was right. Yeah, so if this is 1, then we can get rid of that. Is that not right? Alright, yeah, so I'm pretty sure that's the right way to do it. So we can do that now, and we're not using syscall, so it should work on Windows. So if I compile this all for using mingw, and then go into here, and use wine, so we use TASM to compile it, even though that doesn't matter because it's the same bytecode regardless. And then we use wine. We got to do TASM.exe. Alright, wine tire.exe, open.tim. Alright, okay. So I think I broke wine. I don't think it likes that. Unhandle. Is this an issue with my wine, or is it with the actual file? Yeah, so okay. I think I might have to test this on an actual Windows computer. Because this is not good. And I can't do anything with these error messages. Oh, system Linux. Dang, okay. Yeah. So, very helpful error message. But it doesn't work. That's okay. That's okay. The hello world should still work. TASM.exe, hello world.tasm. exe, hello world.tasm. That does work. So let me remove that debug information. So I will need to test that on an actual Windows PC. So let's actually modify this so we can have write and read. So if I get rid of that and get rid of that. Okay, so we just need to pop off one of them. So the mode. But it needs to be a character. Actually, it can't be a single character though. So should we just push a string, or should it be a number representation? Because well, so what are all the different modes? So let's just look at fopen modes, and let's see what the different options are. Does this have... All right, yeah. So we can read is bytes. Append. Okay, open for... Alright, so I think I'll just handle these for now. Well, actually, we probably could handle them all if we just use a string. So let's do that. Yeah, so basically, we can make this like that, and then this can be... Whoops, I didn't mean to do that. We can get stir from stack. Machine. I think that's all that we need to pass there. And then this can be flag mode. Alright, let's see. So let's go into text and open. So here we just need to push the mode. So we'll do right. And alright, so it didn't work. So why would that be? Let's print what the flag mode is, if we actually get here. We need to interpret it as a pointer though, right? Let's get served from stack. So let's look at the actual implementation of that. So we just return a character pointer, so that should be fine. So let's do that. Open.tim. Alright, so we don't even get there. I'm assuming that's probably where it breaks though. So if I just print that here, alright, and I completely messed that up, but that's okay. So try this again. Yeah, so that's where it stops working. So it doesn't like that. So if I do that, will it work? What obviously won't work, but will it get farther? I mean, no. Okay, so there's something wrong with the strings, I suppose. If I do it like push that and then push W. Not 10. Next. Yeah, so it still doesn't work. So, time for debug stuff. We're not using an actual debugger. So in the get stir from stack, let's see. So in here we can just So let's kind of print as we go. So print F, current, like that. So we are going to get some errors, but that's okay, or some warnings rather. Open.tim. All right, so we don't get there yet. So it breaks before that. So yeah, so we don't even get there. Do we get to here then? Let's see, buffer index, and let's print out the value of that. So it should be 0. So we do get there. So it breaks. Okay. Open. And that's what we're using is fopen. So you know what? It's probably the order though, isn't it? Oh, man, I think I'm stupid. Yeah. So let me go down there and remove that stuff that I added. This basically. Up here, the order that we're doing it, we're trying to pop. No, actually that shouldn't be the issue. So what if we do that? What if we get these things first? So the path and then this, yeah. Okay, yeah, so let's get let me move that there. And let's see. Okay. Alright, yeah, so let me build that. And now in here, let's move this down here. So push. No, we can't move it down there. So let's see. We need to. What do we need to do then? Read, and then on the top. So I'm not sure how to go about doing this. What if we push one, and then let's just then cannot see, and then we'll just basically, instead of getting the string from the stack, we'll do this. Equals pop machine.as in, and we will make this an int, and then this will correspond. Let's see. So basically, we can. For now, I'll just add this in here. So flag mode, and then case 1, we'll just we'll set the what's it called? The blah 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 blah. Open the mode. Yeah, so we'll just do par mode equals double. Like that. And then yeah, we don't need to handle anything else. So then we'll just put mode in here. So does that build? No. So we do need to declare this up here, I suppose. So mode, and we'll set it to right for default. And then we'll do this. What does this mean? So, oh yeah, this needs to be int 64t. Switch quantity, not an issue. So, why is that? Int, and then instead we just do word here. You know what? It's actually because of that. There we go. So now, all right. So let's not Tim. All right, and it's segfault. So okay, because we need to actually pop this off up here. There we go. So now let's try this out again. Open that Tim, test, and it's still segfault. So why? Open dot parsing. Let's see. We push it here. No, so we want to get it first. Yeah, so the first one. So that should be first. Yeah, so this is what we are reading it as. Maybe we want to push it before all of this stuff. So you can assume that there. So just right here, we'll push that. And then we'll go into here. So we want to pop that after the pattern. Alright, and it still doesn't work. So, flag mode. Yes, alright, that's fine. It should still print out properly. And it is 0. So we are not popping it properly. No, open that tab. So open that tab. So let's move this then. We'll put it after read. So the first one, right on top, should be that when we call open. So then we'll put this, yeah, so we want to pop that first because it should be on top. So yeah, that's still the issue, but that's okay. Fire. Best 119. So why is it 119? Pop machine.adds in. That should not be an issue. Let's make it a word. And then pop it just like that. And then .adds in. And default node equal W. Yeah, we'll just do that. Let's break as well. So see test open.tim. Okay. So why is it 119? Alright, flag mode dot as fire open.tim. Okay. So why is it 119? I don't quite understand. Because we should be popping off the top, and it should be 1. So can we print the stack before we pop anything? Right? So have to provide the machine. Alright, and let's go into here. Let's actually let me fix that. And then let's see, open dot. Alright, so we can see the stack now. So we have all this. Message. It is a message. Then 0 and 1. So yeah, so we should be popping off 1 into here. And then this should be that. I don't know why it's nil though. So is that where, but why is this not 1? So flag mode dot as in. Uh-huh. So what if we don't get a switch? And then will it at least work if it's set to W by default? Open that 10. No, so it still breaks. Yeah, so test doesn't exist. So it something else is not right. So is read not working anymore? Well, so read is, because we're doing that. Oh, because it's not. Do we need to? It's content and overwrites the file. Let's create the file first and see what happens. So touch text. Now if we run this, all the way up here, there we go. Text. Yeah, it still doesn't work. So, let's see. All right, in the open, does F open fail? Mode. So the path is not correct, I suppose. Path. Open dot 10. So yeah, it doesn't print the. Yeah, so for some reason that's not working anymore. The read is failed, but it was working a moment ago. So I don't know what happened. So in the read, we do push that as a word. Let's see. Okay, type union. Uh-huh. Well, can we print f buffer? See what it is. Yeah, it's type word, that's okay. So does it print out? Yeah, it does print that properly. Path, yeah. So am I doing does this need to be swapped? No, because I'm printing out the buffer and that's what I typed in. So that should be fine. Build it. There, open 19, test. So I'm not quite sure. And okay. Do I need to switch these around? Alright, and go into here. No, so that is not what the issue was. Alright, let's try this again. And that still works. So length, yeah. So pointer. So what is that we are? That's like the, yeah, get string. So that should be returning standard in. Well, let's just set it to that. Well, no, because that's working. So that's all fine. But when we pop it, it is not working. So what if we make this a word like that? Pop machine. And then the path, we can do path.as pointer. And then in here, we can pass it .as pointer. And let's see. Alright, so it still didn't work. Yeah, so why is it nil? Or null? Why would that be? Alright, let me just let me get rid of that entirely. And then we need to modify the file. There we go. Open up parsing. Not push that there. And then Tim, yeah. Whoops, open up parsing rather. Open Tim as, and then it works. So it's an issue with that. Uh-huh. So it's not pushing properly? Is that what the issue is? That's a bit strange. So after read, it doesn't allow us to push anything? Alright, let me try that. Tin. And yeah, so we don't have any of that on here. Because this is the null termination character. And then this is, yeah, So why is that? Can we do swap 0? So let's just one again. Let's see, does that work? Bring up 10. Then we have this number on top now. Huh. Okay. So that is a tag string. So after we run read, it doesn't want to work anymore. So we push the pointer on there, but then we can't push anything after that. So free close. Okay. Native open. So why is that? Yeah, we can actually cast this so we don't get the error. There we go. Or the warning rather. Yeah, so we can write to it, So why won't it push properly? And then why is this the int that we have first? Oh, because it's a 64-bit integer, I suppose, is why it is like that. So that worked. Actually, let me go to here. This one again. We could just do it, but it doesn't matter. And then we'll install it's 0. And then in here, if we do this now, we should be able to print it out. So let's not do that. And let's do flag mode dot as in, and this needs to be long. Build this again. Let's recompile it actually. Open.adsm. Open.tim test. Alright, so it didn't work. Because of reasons. It didn't pop it off. Or no, it did. But then let me try that again. Test. Yeah, and the test wasn't created. So, but we did get the 1. So, did not see. So why is that? It should be popping it off, and then alright, let's print the flag, or the mode rather, is that, and then the path is that. We'll need 2 new lines, and we'll just do path.as and not tim. Yeah, so it's not getting that. So, because this, it should be popped off though. So let's print the stack after we pop all these off. Open.tim. So, alright. So yeah, it didn't pop anything. Or is this the top of the stack actually? I suppose so. Yeah, I think it is actually. Now that I'm looking at it, it prints this. So this is the top down. So I was thinking it was bottom up. So I suppose that could be a thing. Actually, though, we do break it by swapping it like that. Yes, that's actually what is breaking it. What happens if we do that? So, alright. Okay, and like that. Alright, so I seem to have worked actually. So what is different? We can't do that though. Oh. So wait, yeah, it just prints test because the length is set to full. But yes, that seemed to work. So, yeah, I was reading it the wrong way, but we don't interpret the path at the moment. So it doesn't matter what you put, but yeah, so why was it not working before? I don't quite understand. Well, let's see. So are we gonna use it for anything else? I don't know. So right now I'll just do this. Flag mode by as in, and then case 0. So 0 will be read. Case 1 will be write, and then case 2 will be read and write. Read like that. And we'll break. Yeah. So I'm not gonna handle all of them yet. Well, actually, yeah. I'll just do this for now. So we'll do mode equals that, or mode equals that, or that. So we can add the rest, but yeah. So that's basically what it will correspond to. And then, yeah, so let's test if that works actually. So let's just print the mode here. So we can put that as a string. Yeah, so I didn't rebuild. Alright, and alright, did I forget the break? Alright, I forgot a semicolon. I've never done that before. Yeah, right there. And alright, everything else seems to work, so let's run that. Recompile just in case. So Yes. All right. And then the mode is right. So if we open that cousin and we change this to 0, then it should fail because we're trying to write. So we compile it and then run that test. Only new test actually. So did it? Yeah. So then it broke. Because yeah. All right. So that is good. And then if we do 2, then it should be read and write. So let's try that. Test, and there we go. So that seemed to work. So I suppose that is all good then. Yes, indeed. So we'll still set that there. By default, it'll just be right. Yeah, and it'll be pretty easy for us to add the rest. There's probably a better way to do this actually. If we have like an array that could correspond to these values. So if we do something like let's do character write modes, or open modes rather. Open mode equals actually this needs to be that, and then read write, and then we can just do mode equals open modes, and then the index of flag mode that as int. Well, so then we do need to check if it is greater than that, but for now that should be fine. Get rid of that. Change this to open modes. Alright, and then we can get rid of this whole thing. And then let's see if it works. So let me think the modes again, actually, just to make sure. Mode. And let's compile that, and we have some issues. Yeah, okay, so this needs to be a like that. Whoops, that messed it up. Because I accidentally closed it improperly. Alright. Yeah, so that won't work. Forget how to do this. And then 3 is the length. Alright, and then if we go in here, chasm, then fast, read, write, read. Okay, so I think that's right. Alright, and then open dot chasm, and if we change this to 0, then it will follow. Test, and there we go. Alright, so it didn't fail because it already existed, but that's okay. So, whoops. Wait, what? Oh, yeah. There we go. Yeah, so I need to delete swap file again because I messed it up. But yeah, so this can be, we can hashtag define, modes length, and level 3. So modes length. And then we'll just do if flag mode is greater than modes length. Then we can do this. Error, mode not out of bounds, I suppose. Out of bounds. 1, and we actually have to provide flag mode that as int, and we should interpret this as int as well. And now we shouldn't be able to go out of bounds. And that is actually not just a regular one. Long. There we go. So let's go into here, and now actually we have to modify it. Open that chasm. So let's try to push 4, which should be out of bounds. Open that chasm. And that Tim, just like this. Test, and then mode 4 out of bounds. Alright, so that is perfect. And then so we could make macros to sort of correspond to that. It will make the error messages a little harder to read, but that's okay. So open that chasm, that Tim, test, and it broke. Okay. So why? Why did it break? So perhaps I messed something up in here. So it gets past here. Oh yeah, so it actually it needs to be less than the length as well. Because 3 is out of bounds still. So that is what the issue is. So now it'll be out of bounds. Test out of bounds. Alright, yes. So that fixes that. So we have to push 2 actually if we want it to be read and write. And it should work. There we go. Yep. Alright. So let me get rid of this print stack that we have and that. And I think that is all that we are printing. Do we have any more down here? Let's see. So got 10 test. Alright, perfect. So then we have the test file and we can modify the message in it. So push, we can actually create a, yeah, that could be kind of funny. If we do push 10 and then push 5, let's see, push 5 and then add and then print. Yeah, I think that'll work actually. So if we TASM, whoops, TASM, there we go. Open that 10 test. And alright, I actually did not allocate enough space, right? No, because we're not allocating for that. So, it doesn't like that. I think I know where it's failing, actually. In the... Yeah, alright, so let me go into here. So in here, the get stirred, stirred from stack. I think that we don't have enough memory. And then we're trying to reallocate it, and it's not valid. Let's see, so that might fix it. No, alright, so let me open here. Let me get rid of the reallocate, and then change stuff. So, yeah, we don't want that anymore. And let's see. Okay. So, yeah, it doesn't work at all. I'm not sure why, though. But it doesn't like that. We can just push and then print. Let's just do that. Let's make it a bit simpler. And let's see. We got 10 test. Alright, and then if we get test, push 10 and print. So now we can actually build test, and then run test.10, and there we go, it prints 10. So we actually generated some of the titanium assembly TASM from the TASM file. So that's pretty cool. And we can remove those. Yeah, I do think that it's quite cool. Kind of hard to read like this, but that's okay. Yes, indeed. So there was an issue with the memory management, so we can only get strings so long. But I will fix that off stream. But yeah, so now this all works. And then let me actually build it on Windows. Not on Windows, but .sh. Alright, and then yeah, so it doesn't like that. So actually I need to do something different. Which is because Windows Int64 is long int, but then on Linux it's just long int, so it makes things confusing. But if I go down here, I can show it. We can actually use this, which is in a library. I guess it's all the way down here. Let me see. Yeah, this yeah, like that. So if I just take that, and then we can use that in here, like that. So let's do something, something like this. So percent, and there we go. So now that should work. If we build it, actually on Windows, there we go. And then let's see if it works. So I don't know if it will, because it wasn't working before. In test. Yeah, so it doesn't like incorrect mode flag OR. Yeah, so it doesn't like that. And I'm not sure why. So that's something I'll need to look at. Yes, so what do we need to do now? I think I'm going to have to kind of change how the strings work, because right now we just push them like this, but I think we're going to need like a different section. So in x86, 64, NASM assembly at least. You have something like in like actual native assembly, you have something like that, and then you put like the name, and then db, and the string that you want, and this will actually store it. So I think we're gonna need like a different stack, the data stack, which is where we push any strings and such. And then everything else, yeah. So you would just define this like up here or whatever, and then you could use it where you would do well, you wouldn't even need to push it really, but you could reference it, right? So you could push the pointer to it. So yeah, if you push stir, that would push the pointer to the top of the instruction stack, and then you could use it with the right. So that's probably how we're gonna have to do things. Not exactly that same syntax, but a similar thing to that. And then the rest, yeah. So perhaps we could use just a different instruction for that, because then that stack could just be a stack of strings. Um, and I think that would be better. Um, yeah. So if we had that, so what would that look like? So maybe like push stir, something like that. Test, something like that, and then that just pushes it to the data stack. And then we're gonna need someone to reference it, so you know that this is in a label or something. Maybe if you just do like move stir, then that would just take it off of here. Well, no, it would leave it on there. Yeah, so that would always be on the. So you would probably just put the index of it. I guess we could just use indexes. So starts at 0. So move start 0, and then that will get the pointer to this, right? So right here. Um, I don't know that I like that as much, but I think that's going to work a lot better for our purposes. And then that would just be the equivalent of this. So then we have that there, and then we just call right, and it puts that pointer into right, essentially. So maybe I will get started on that after a quick break. Yeah, so like 5 minutes. So let me just break 5 minutes. There we go. So I'll be right back. Okay, I am back. Did the stream die actually? It is not loading for me. Give me a moment. Let me see. Uh-huh. Alright, I think it's working actually. So, looking okay, I think. Hopefully. Yeah. Alright, so I'm back. I apologize for that. So let me actually zoom out a little. So, yeah, so let's look at, what was I just, I guess I got rid of it, but actually from the hello world, isn't it? Yeah, so we won't have that. We'll have push-dir test, and then you reference it with an index. Yes, that should not be too difficult to implement, and then we can just get rid of that. So, yeah. So let's see. So how are we gonna go about doing that? In here, right now we push and push pointer. We can do push stir. That has to be different because it is gonna be on a different stack. So, yeah. So let's go into 10.c. I still have the problem with the swap file. So down here, and it won't be a native instruction. It'll be an actual instruction. Yeah, we can just add that into here. Let me just search for push. Yeah, push stir. So, that is going to push, we can name this push stir. And then this will be, so the machine's going to have a different, yeah, a different one. So, okay. So we'll have on the machine, that's defined in here, I think. Machine, yeah, we have the word stack. So then we need a character stack. So, character stack, which will be max stack size. It can be the same as that, but it also is a pointer like that. So something like that. So that's going to take up a good bit of memory, but that's okay. So then we'll also do stir stack size. Yeah, so not character stack, but stir stack. Something like that. So machine, let's see, Bandito, if I pronounced that correctly, followed. Thank you, I appreciate that. Yeah, so we need instructions is in here. So that's the list of, yeah, so the stack, so it's going to be, so I guess we can push it on there. That's not going to work though, because so we're going to have to think about how to store this in the bytecode. Because, yeah, so we can have the stir stack where we push, let's see, so let's go up to push, let's see, push pointer. Let's look at that one there. Pointer right here. Nope. Yeah, so push pointer, we want push. I should really change the order of this actually. This can go up here. Yeah, the original push should come first. This will be push stir. So this is going to take a character. And then we're going to set machine stir stack to machine stir stack size plus plus equals value. And that should be all that we need to do for that, I believe, if I'm not mistaken. But yeah, so we need a way to represent that in the memory. Because right now we just represent it in byte section. So yeah, so I'm going to have to look into that. But yeah, so we should have that now. Let's see, will that actually compile? Because we don't have some stuff. Argument 2. So that's a word. Yeah, so this needs to be so we can't push it from the instructions. So we need like 2 segments of the in here where we have write program to file. So the first part we can probably write as the let's see, as the strings and the raw data. And then the second part, yeah, so let's actually have data. So let's see, so data like that. Actually, could we just push it to the string stack and then write the string stack like that? And then we don't actually have to push to it in the program itself. It should just be red. I think that could be a thing that we could do. So let's look at this. So if we do file equals fopen file path, and then we open it as write, just regular write. Let's see. Hello, hope you're doing fine. I am doing fine myself. How are you doing? So then this will be a pen, because we're going to pen after. And we can get rid of this. So yeah, and we need this check. And then what we can do is fwrite. Yeah, so this is writing. So the file is the last part. And then machine. Let's see. So machine. Let's machine stir stack. Stir stack. Size of machine stir stack 0. Machine stir stack size, something like that. Will that work? And then yeah, we can F close it. Alright, let's see. Alright, and let's see. So yeah, then we can take this from the stir stack directly. Well, do we even need to interpret it here then? Well, I'm not sure. We'll figure that out. But for now, we'll just do that. Stir stack. And we'll just use IP because it's just a placeholder. Expected. Okay, expected semicolon. So did I... Alright, let's go up here. Left operand has no effect. Oh, yes, okay, I see. I did not... That's in a read. So it's right here. We did not close this. Alright, so that compiles. But now we need a way to do it in the chasm itself. So in here, if type is push, so let's do, we'll have a new one. Actually we can do push or head value dot type equals type push push stir, like that. Then it's always gonna be string that follows it, because we'll check that in the parser. And we want to push stir, and then we can just push the let's see. So yeah, so I think we might need a struct for this, because here we have the value and the type. Okay. So what if we do, where do we return the, so the program is an instruction. So maybe this should be handled separately, and then we can return that. So if we, so how am I gonna do this? Well, so we could pass the stir stack, basically. Stir stack, it's stack size, and yeah, I think we have that actually. And then we can do stir stack, let's see, stir stack size plus plus equals, let's see, head value dot text, something like that. Then that should set that. And this, yeah, so I don't think we need that. And so this will just modify the stir stack. So we do need the stir stack size. So, yeah, perhaps that can just be global. That's maybe not a good idea. So int stir stack size, and we will make that, maybe I'll just make it global for now. Yeah, just int stir stack size, something like that. And we'll set it equal to 0 initially. Yeah, so we push that. And then we can just get rid of all of this. And it's saved on the GitHub in case I revert any of these changes. And then we don't need that stuff. We don't need I. So yeah, that should all be all that we need to do. So we do need to actually add this to add this to the lexer. So in here, we need push stir, and then lexer, oops, there we go. I can't, let's see. All right, there we go. Let's see. Was having some issues. So then right here, we can take this and then stir, push, stir. And then let's see, push, enter is next. Let's see, push. Yeah, right here we need to do push, stir. This is what defines the actual keyword. Type push, stir, just like that. All right, and I think that's all that we need to do in here. So now in the parser, basically, yeah, so we need to check this separately. So if lexer token stack index dot type equals type push stir, and then I should have a function for like expecting tokens, but I don't have that. Then we'll do index plus plus, and then current token equals lexer token stack index. Okay, I'm just basically kind of want to add up here, and then lexer index dot type does not equal type stirring, like that. Then yeah, we can do this. Otherwise, we'll append root lexer token stack index, and that should work now. Okay, so if we make a test.chasm, and then we open that up, test.chasm, and we do push stir hello, like that. And let's see. So then let's just try that. And so does it compile? Okay. So yeah, I need to modify that. That is where I changed all that stuff. That was here actually. So chasm.h. So here we need the character, and then this is the stir stack, max stack size, and then we also need the, no, we don't need that. Yeah, so let's see, does that compile? So too few arguments. Oh yeah, so we don't actually add the arguments that we need here. So stir stack. So let's just do stir stack max stack size, like that. And now, all right, now we have other issues. I forgot a semicolon. And okay, so that actually worked. So let's compile test.chasm in. So stack underflow. So what actually, let's print the list that we generate, and let's make sure push stir, and then we have the actual text. So all right, that is good. So let's actually do a hex dump of the test.tin file. Okay, so we have that. So let me see. What do I have? Let's see. Let me get rid of some of that stuff. And let's go back to tim.c right here. So we don't want to open this for reading. We want it writing. Oh, that is for the reading one, actually. So yeah, so when we read it, yeah, we don't actually populate the string stack. So we need to do that some way. Yeah. Okay. But Tim. Okay. So I'm not sure if it's working properly, but I think we can actually do this, and then we can do dot stir stack equals stir stack, and then also the stack size, stir stack size equals stir stack size. That is a funny thing to do. And now missing initialization, so equals stir stack. Let's see, did I do Let me open up .h again. So the stir stack. So I don't understand why that is not right. Alright. So it doesn't like that. Missing braces. We have the braces, so okay. Yeah, I'm not sure why that is a thing. Let me zoom out just a little. Yeah, there's braces on there. So why is the stir stack not a double stack? Yeah. So that causes a lot of other problems there, but yeah. Okay. So then if we modify the push stir, yeah, right up here, where we just, well, let's do that. Yeah, no. Yeah, all right. So let's do that. And then missing braces. So I don't know why it says that. Uh-huh. Stir stack. It's right here. All right, let me actually, well, let's make sure that works. So I'm gonna assign that one properly. Okay, let's do machine.searchStack equals searchStack. Expression. All right, so you can't. Let's see. You can't just assign it like that. Doesn't want that. Okay, so I might need to rethink this whole thing, kind of. So what if we define the machine up here? Machine, and then basically we pass the machine stir stack, right? Machine stir stack, rather than setting it here. And then, yeah, then we have to do each one of these like this. Machine.instructions, program, machine.program size equals program size. And actually, I think we need to do something like that. Machine. And then, yeah, because then that will actually modify it. And then machine dot stir stack size equals stir stack size. We can get rid of that. Okay, and let's see this. And that right there. Unused variable stir stack. Yeah, so we can get rid of that now. Yeah, so then we need to do. Well, yeah, let's actually just go like that. Then, okay, machine dot stir stack. And let's see. Expected character, but argument. Alright, so generate instruction. Okay, okay, and then TASM, test.TASM. Okay, so I don't know if it did anything, because we're not actually populating it, so I don't know that that's gonna work. So let's actually that's not 10. That's 10. That's not. Okay, so we do have more data. Okay. So is it writing properly? So where are we writing actually? It's down here. Whoops. Right program, there we go, it's right here. So, right, okay. And then do that. And then close it. Okay. So when we read it, first we want to read it. Yeah. So what if we get rid of, just for testing, get rid of that. And then build that. Then we cat, let's see, test.10. Okay. Test.10. Yeah, so I'm not sure if that is working. 1, 2, 3, 4, 5, 6 bytes. Alright, well, so that is the proper amount of bytes. Alright, well, let's try to read it. So I think we need some sort of separator, where we just push like a value. Right, so basically we set the last value of stir stack, like stir stack size, and we actually need to prepend this with machine, like that, equals what? So it should equal, it needs to be something that isn't used, but yeah, I don't know. I think what we can do though is when we open it, so instead of seeking to the end, can we just seek to a character? So let me look at that actually. Fseek to character. Let's see. Not ink. Yeah. Whenever it loads, fseek. Alright, so let's look at this. Because then we could get the character and then read that and then start it there. So offset and then position. So yeah. Position. Let's see, end. The beginning of the. Alright. So what is a good way to go about doing this? So because this just reads the instructions, and we don't really want that. So does it, let me see, does it create that kind of instruction? Test.pattern, test. Okay, so it doesn't actually do that. I think it's all just gonna be notes then. Yeah, I need to rebuild it, and then, alright, so I don't know what it is then. It might just be nothing. So, in here, how are we setting it? So we do that. So let's actually iterate through the, I is 0, while I is less than machine.stir stack size, and then print f. And let's just print machine.stir stack I. Let's see what it does. Alright, so we do get the string. So if it's writing it properly, it is different though. So how do you so let's see. Let's do C read to certain byte or certain character. Because then we could open, because the first section would be the data section. And then we can just open it and then read until it's well, for now we can do null termination, but then we can decide on a different character. So yeah, this is using fgetC. Is there a different way to do that? Uh-huh. So it's taking a while to load. Yeah. Fine. Alright. Yes. So how is that different from get C? Let's see. If open, it's not equal end of file. Yeah, so we don't want to look till end of file. So alright, well let's do file equals f open file path, and then well actually if we write well let me see if I can hex.test.10. So which one is the null termination character? So let's push another server which is empty and do a couple of those. Let's see, actually that might not fit. I don't know if it's set up, but let's not have it. Alright, and then test dot let's hex though. Alright, so which one is could it be 55F or 558F? 1, 2, 3. Yeah, so we should have 4 of those, and there is 4 occurrences of that, but I guess all of this stuff occurs. Well, so let's look at hex to ASCII. So what does this look like? Yeah, this one is good. Yeah, so it's probably just gibberish, kind of. But if we read it, yeah, so it's just gibberish. But it should represent that. Should represent hello. Alright, oops. Test.10. No, test.10. Okay, so, yeah, so it is different, the first parts of it. Yeah, so I'm not sure. So yeah, so I want to read. So what if we f read into pair stir stack with side of let's see actually stir stack max stack size, something like that, and then f read into stir stack, and then let's see, side of stir stack 0 length and file. So what will that do? Test.10. Okay, so can we print the stir stack then for this? So we need the program side also. So, or the, well, for now, I guess we could do machine stir stack size equals length. So we'll just do that. Yeah, for now. So then let's iterate through. So, oops, for int I equals 0. So basically the same thing that we did in here. We could probably copy it then. And then just change the dot to change it to an arrow like this. Let's see. Alright, so it segfaults. Yeah, so I'm not sure it's saving it properly. So how do you write? Let's just do write sir to wait. Oh, let's see. Let's see what comes up for that. So what if we do y is less than machine stir stack size by plus. And then we just do this. So let's open it for a pen like that. And then we just write it. Yeah, so we write like that, and we do machine serve stack 0, and we make this just 1. Uh-huh. So what will that look like? Alright, that's not padding. And then hex dump, that's dot in. Okay. We have an exclamation point in there. Not in there though, so. Okay. So, yeah. And let's jump again. Oh, you know what? Since we're appending, yeah, actually, let's just do right. Because it was stacking up. Yeah, but is it the same? It's not. So, but it is the pointer to it. So here, okay, well, so let's see now. When we try to read it, test dot pin, still say false. Okay. Yeah, so that doesn't work. I'm going to need to rethink this entire thing. Man. Okay, well, so I have been streaming for about 2 hours and 10 minutes. So I'm probably gonna, haven't done any commits. I'm probably gonna have to end the stream. And I can continue working on this off stream, and hopefully I get it working, and then next stream I can talk about what I did. Yeah, so, yeah. So it's gonna end it. If anybody wants to say anything or something like that, then now is the time. Yeah, so that's not what I want. So yeah, I will end it in a moment. Hi, been lurking. Lurking is good. How are you doing? I usually lurk. Uh-huh. Data converter. All right. Okay. You are all right. Is something wrong? Yeah, so it doesn't like that. So this does it's like that, right? No. Alright, so it just won't convert. I don't know how it works. How was stream? Stream was good. I didn't get to finish what I was working on, but was a decent otherwise, because I did get some other stuff done. Some other good stuff. Okay. Yeah. Let's look at Python implementation. Okay. So let's see. Yeah, B string. Let's see. C decode byte. Let's see if there's something for that, and then I will end the stream. Working with bytes. Not base 64. Code UTF-8 byte. I think that's what it is. Uh-huh. Yeah, so that's not really. Alright, yeah, so I'm gonna have to end the stream now. So I'll try to get this working off stream. Yeah, so I will see what I can do about that, and I will talk about it next stream. So that's gonna be